So beginning with the first question of DP section in CSES program set, and the first question is dice combination, where we need to count the number of ways to construct some n by throwing a normal dice. Means it will have only 6 faces. So let's see an example. For getting 1, there will be only one try, like dice will roll 1. If it's rolling 2, there is no point of counting it. So for getting n1, there is only one try. For getting n2, there can be 2 tries. First time dice roll ups to 1, another time also roll ups to 1, or it directly shows up as 2. There also will be 2 ways. For 3, 1 on the first roll, 1 on the second roll, 1 on the third roll. Or 2 on the first roll, 1 on the second roll, 1 on the first roll, second on the second roll, and third directly. There will be 4 ways. So basically what we are doing is we are just making us an iterator 0 to n by adding 1 to 6 numbers. That is the only iteration of this question. Like we want to get reach to 4 and count the number of ways from getting, we want to reach 4, we want to count the number of ways to get 4. So we start from 0, we want to reach 4. We firstly added 1 to 4, the 2, we added 2, we added 3, we added 4, we added 5. 5 will be get out of bound for this end, so we will not consider this case. And in 1 comma 4, we added 1 again, 2 comma 4, 2, 3 comma 4, and 3, 3 comma 4 comma 4, and next will be out of bound. We added 1, 3 comma 4, we added 2, 4 comma 4, next will be out of bound. We added 1, 4 comma 4 only. So and now we can add there 1, that will give us 3 comma 4, or add 2, 4 comma 4. Only one can be added, 4 comma 4. Only one can be added, 4 comma 4. So there will be 1, 2, 3, 4, 5, 6, 7, and 8 ways. And now we can see 3, 4, 3, 4, 3, 4, 2, 4, 2, 4. The cases are repeating itself. So whenever the case repeat, what we use is like DP. On what we will use the DP, like indexes 1D, 2D, 3D. So that will be on only, we are taking only one parameter, that is reaching towards n by adding 1 to 6 numbers. So we will create DP of n plus 1, and recursive calls will be like if base case I is equal to 0 and we return 1, I is greater than n, we return 0. This will be the base case, and the process will be like we for 1 to 6 we are adding 6 number every time on each call. Answer plus will be equal to answer plus, not this plus next call for I the iterator of ours, and this number plus let it be j plus j comma n for matching, and we will just return this. Now introducing DP, and like DP of I will be equal to answer, and we will check if DP of not equal to generate minus 1. So this is the basic intuition. Let me show you the code. So just generating a DP of n plus 1 and minus 1, and right, returning the solve for it starting from 0. So we need to go from 0 to n, and uh, the recursion will be like I, n, and dp. These are the base cases. If I greater than and return 0 of n, return 1, and if dp is like overlapping cases, the one case is already done, we will directly return it. That's the main dp. And starting from answer 0, for each roll up we are adding if it is in the bound, and just returning the dp. So this will be the memoization solution. Moving on to tabulation, if we just directly converted this approach from tabulation, like bottom to up or top to down, it will show up like that. dp of 0 will be 1 because we reached 0 from n to 0, bottom to up. For each sum, like we are going from 0 to n, there for each we are adding 6 if it's in bound, I minus j, because we have to opposite the signs. But like we can also think of this question directly in tabulation way. Like, it's an easy question. For n is equal to 1, there is one way. For n is equal to 2, there are two ways. For n is equal to 3, there are ways like 3 getting itself, and number of way we can reach 2. 3 getting itself is 1. Number of ways we reach 2 is 2. And number of ways we can reach 1 plus 1. This is exactly getting for other is from 3. There are 3 ways. From 2, there are 2 ways. From 1, there is only 1 way. That will add up to 8 ways. So we can just see dp of I is basically dp of sum is equal to dp of I minus j, and j will be go from 1 to 6 if it is in pound, like I minus j is greater than equal to 0. We can just directly write its tabulation approach. But like starting from basic, you can go like this. We want to reach from 0 to n by adding 1 to 6 numbers, getting the recursion calls and seeing it overlap using dp. But we will use dp on sum. Dp of I will go to n plus 1, so we're writing dp of n plus 1, writing the base cases, then writing the process you did there, and just easy question. See you next time.